Hello all, welcome to this session where we discuss on water chemistry. And this video is useful for the students under VTU curriculum. Myself, Kiran Kumar P, Assistant Professor, Department of Chemistry, ATME College of Engineering, Mysuru. Today's session, we discuss about the introduction, sources and impurities of water, and we will see the boiler feed water and the boiler troubles with the disadvantages. And in boiler troubles, we are going to see the scale and sludge formation and the boiler corrosion due to dissolved oxygen, carbon dioxide, and magnesium chloride. Let us move on to the introduction part. Let us see the sources of water. The major sources of water is the rainwater, where the rainwater is least contaminated and it doesn't have any impurities in it. Seawater, and the seawater is one of the major source of water which has the highest amount of dissolved salts in it. And river water, lake water, and finally the underground water. So these are the some sources of water. Now we shall see the impurities present in water. So the impurities present in water are dissolved impurities. So generally the water has the dissolved salts in it, such as calcium, magnesium, sodium, and the various soluble salt from oxides of magnesium, iron, lead may also present in water. So all these salts will be in a dissolved condition. And the suspended impurities. The water also has the impurities in the form of suspended particles, the solid particles, such as it can be further classified as inorganic and organic suspended impurities. The inorganic suspended impurities such as clay, silica, oxides of iron and manganese. Similarly, the organic suspended impurities includes wood pipes, dead animals, leaves, fishes, bacteria, algae, etc. So these are some examples of suspended impurities. Then the water also has dissolved gases in it, which contains the dissolved gases such as oxygen, carbon dioxide, sulfur containing gases, ammonia, oxides of nitrogen, etc. And water also has the organic matter as an impurity in it, such as the decay of vegetables, animals, bacteria, etc. And also the human excreta such as sewage and human excreta. So these are some of the different kinds of impurities present in water. Now, let us see the boiler feed water. So generally the water is used in boilers, that too in industries and the power plants, in order to generate the steam. As you all know, steam is a very good source of heat energy. The boiler water is used in a boiler for generating steams for industries as well as the power plants. The boiler feed water, before feeding it into the boiler, it should have some characteristics. The water should have the hardness in the range of 0.2 ppm. It should be below 0.2 ppm. And the alkalinity should be in and around 0.44 ppm. And the carbonate containing salts, it should be below 1 ppm. Let us see an animated video which clearly explains you the boiler feed water. And the video is taken from, the video credit goes to the YouTube channel.
Explain boiler feed water and Boilers are used in industries to generate steam, which in turn is used to generate power and heat. Thus, boiler is a device for generating steam. It consists of two main parts, furnace and boiler proper. Furnace provides heat by burning the fuel. And boiler proper is a device where water changes into steam due to heat. This steam or hot fluid is then recirculated out of the boiler to be used in various processes in heating applications. The water which is fed into the boiler is called the boiler feed water. These days, modern boilers require high-quality water to operate efficiently. But such water can never be obtained from any of the natural sources, as it contains certain impurities. The presence of impurities in the water makes it unfit for use in the boiler. So to make the water fit for use in boilers, using various techniques. Thus, we can say that boiler feed water is specially conditioned water which is fed into the boiler to generate steam or hot water. It is generated through a system of heat economy. Steam produced in the boiler is condensed after use and is returned as pure feed water called the returned water. Then some fresh water or make-up water is added to this returned water. It is this combination of returned water and make-up water which is fed into the boiler. As the boiler feed water to generate steam. Note that boiler feed water depends upon the quality of the make-up water and the amount of condensate returned to the boiler. Sometimes we see that some impurities settle down at the bottom of the boiler after the steam is produced. We know that steam which escapes from the boiler normally contains liquid droplets and gases. So the remaining water at the bottom of the boiler might pick up all the foreign matter from the water that was converted to steam. This results in the accumulation of impurities at the bottom of the boiler. These impurities can be removed by discharging some water from the boiler to the drain. Such process of blowing the impurities from the boiler to the drain is called blowdown operation. In order to operate and maintain a boiler system efficiently, it is important to treat the boiler feed water properly. This is because when steam is produced, the dissolved solids become concentrated and form deposits inside the boiler. This leads to poor heat transfer and reduces the efficiency of the boiler. Also, the dissolved gas, such as oxygen and carbon dioxide, react with the metals in the boiler system, and this leads to boiler corrosion. Thus, to protect the boiler from such contaminants, the boiler feed water should be treated properly through external or internal treatment. Let us now discuss the specifications of boiler feed water. Before using the boiler feed water in the boiler, it should be made sure that it meets the following specifications. Its hardness should be below 0.2 parts per million. Its caustic alkalinity should be between 0.15 and 0.45 parts per million. Its soda alkalinity should be between 0.45 and 1 parts per million. It should be free from turbidity and sediments. And it should be free from organic matter, oil and grease to avoid foaming.
Hence, boiler feed water should have some characteristics in it. So it should be free from all impurities. Now let us see another part, the scale and sludge formation. So these are the boiler troubles which occur due to the presence of some impurities present in our water. During production of steam, water is continuously heated under pressure in the boiler, as you have already seen in the animation. The evaporation of water increases the concentration of dissolved salts which precipitates and it reaches to the saturation level. This also you have seen in the animation. So due to the saturation level, the salts will be deposited in the boiler, which in turn the precipitate formed, they are thick and they strongly bind on a wall of a boiler, thus creating a scale. The thick and hard sticky layer which is formed on the surface of a boiler is called as scale. On the other hand, it also has the loose adherent precipitate which will be suspended on a water, that is called as sludge. It is clear here, this is a boiler wall and this is a boiler feed water. Due to saturation level, there is a scale formed on a surface of a boiler. In this image, there is a sludge formed. Sludge, as I said, it is a suspended precipitate present in a water. Sludge is also formed. So this is about scale and sludge formation. Let us go in detail. Let us see the causes for scale formation. When water is heated to generate steam, the water will be evaporated and which causes the precipitate, it becomes and saturates and it will be accumulated on a surface of a boiler as seen in a previous image. The sticky layer, we call it as scale. This part is a scale. The scale is due to the presence of calcium sulfate, where calcium sulfate at cool condition, it will be a insoluble state. The calcium sulfate will be soluble in water at cold condition, whereas at very high temperature, it becomes insoluble. Therefore, at very high temperature and pressure, it gets precipitated and deposited in the form of scale. So calcium sulfate will be deposited in the form of scale at very high temperature and pressure. Similarly, the decomposition of bicarbonates also forms scale. You can see in the reaction here, the magnesium bicarbonates will undergo decomposition at the high temperature. As a result, magnesium bicarbonate is converted into magnesium carbonate and carbon dioxide, water will be liberated. So magnesium carbonate also deposits in the form of scale. And also presence of silica impurities in water, which in turn converted into calcium silicate and magnesium silicate. It also accumulates in the form of scale. And hydrolysis of salts of magnesium. So magnesium salts like magnesium chloride undergoes hydrolysis in presence of water at very high temperature to form magnesium hydroxide. So magnesium hydroxide is also insoluble precipitate which accumulates on a surface of a boiler in the form of scale. It liberates 2HCl in it. So these are some causes of scale formation. And let us move on to the causes of sludge formation. As I said, sludge is a loose aggregation of impurities, that is the precipitate in a water. Generally, the precipitate is formed at the cooler part of a boiler. If the sludge is not removed continuously properly, it will lead to formation of scale. Let us see some drawbacks of scale and sludge formation, disadvantage of scale and sludge formation. There will be wastage of fuel. Since the scale and sludge formed are bad conductor of heat, we need excess of heat to boil the fuel. Hence, there will be wastage of fuel. And also there will be danger of explosion due to scale and sludge formation, and also there will be the carbon dioxide, oxygen and MgCl2 present in a water, which leads to corrosion of boiler So boiler will be corroded. As a result, boiler may get brittle, and there may be a explosion of boiler, which will lead to major disaster. And it reduces the efficiency of a boiler. Because of deposition of scale, boiler parts may get choked, and efficiency of a boiler decreases. And there will be increase in cleaning expenses, because to remove scale, it requires periodical maintenance. Hence, cleaning expenses is also high. Let us move on to another part, boiler corrosion. Boiler corrosion is defined as it is a decay of boiler material due to presence of impurities in the boiler feed water. That is called as boiler corrosion. And boiler corrosion is mainly due to three factors. Corrosion due to dissolved oxygen. So water has the dissolved oxygen in it, normally between 8 to 9 ppm. When it is heated to very high pressure and temperature, the free oxygen gas is evolved and it reacts with the iron. Free oxygen reacts with iron to form FeOH twice, which is an insoluble precipitate, which again undergoes oxidation in presence of water to form the corrosion product, what we call it as hydrated ferric oxide, Fe2O3 3H2O. Hence the boiler will be corroded. This is an example of corrosion of a boiler due to dissolved oxygen. And the second type is corrosion of boiler due to presence of carbon dioxide. The water also has carbon dioxide in dissolved form, and also there will be carbon dioxide liberation due to some decomposition reaction, such as calcium carbonate undergoes decomposition at high temperature to form calcium carbonate. Calcium bicarbonate is converted into calcium carbonate with liberation of carbon dioxide and water. Similarly, magnesium bicarbonate also decomposes to form magnesium hydroxide plus carbon dioxide, which then the carbon dioxide formed and water, the carbon dioxide and water combines together to form carbonic acid, where carbonic acid is slightly acidic in nature and it is more corrosive. So that was about the corrosion due to carbon dioxide. Let us move on and see the corrosion due to magnesium chloride, where the magnesium chloride present in water, it drops the pH below 8.5. The drop in pH is due to the reaction where magnesium chloride reacts with water hydrolysis reaction to form magnesium hydroxide, which is a precipitate with liberation of 2HCl. And during the reaction, the HCl liberated acidic medium causes the corrosion of boiler parts. For example, the HCl reacts with iron to form FeCl2. FeCl2 again undergoes hydrolysis to form FeOH twice. Again, HCl is liberated. Hence, the corrosion will be again initiated. So this is about corrosion due to magnesium chloride. Let us see a small animation. The credit of video goes to After Tutor.
Today's topic is all about boiler corrosion. Previously, we discussed a form of corrosion which is infused in the metal of the boiler feed water. Likewise, now we are moving to a similar topic called boiler corrosion. Boiler corrosion is due to the presence of dissolved oxygen, dissolved carbon dioxide, and dissolved salts like magnesium chloride. Dissolved oxygen. We know that the corrosion is a natural process which converts the metal to its oxides, sulfides, or hydroxides. So, it's clear that the oxygen plays an important role in corrosion.
When water is fed to the boiler, it contains dissolved oxygen, which is then heated to evolve free oxygen. The evolved free oxygen corrodes the boiler material. Let's take a look at how dissolved carbon dioxide causes boiler corrosion. When water containing bicarbonate is heated, carbon dioxide is evolved. The evolved carbon dioxide makes the water acidic. Carbon dioxide, when reacts with water, forms carbonic acid. The formed carbonic acid causes corrosion in the boiler, which is called as pitting, nothing but the localized form of corrosion. And it is responsible for the occurrence of small holes in the boiler metal. The appearance of holes in the boiler metal is what pitting corrosion is all about. Dissolved magnesium chloride. When water containing dissolved magnesium chloride is used in the boiler, and by heating, hydrochloric acid is produced. Hydrochloric acid is a strong acid, which has the ability to corrode metals. In the boiler feed water, hydrochloric acid attacks the boiler in a chain-like reaction, producing HCl over and over again, so that it corrodes the boiler severely. This chemical reaction can prove the natural process of corrosion. So, that's all for today.
So that was about the corrosion due to carbon dioxide, dissolved oxygen, and MgCl2. Thank you.